Hey everyone, my name is Andre, and in this demo I'm going to show you how to solve one of the most annoying problems with GitHub Actions, IP allow listing. Sometimes your CI runner just needs a predictable IP address, maybe to call a third-party API, hit an internal service, or deploy into a lockdown environment. And if only you could give your runner a predictable IP address. But instead, GitHub's runners appear to be using a massive range of IP addresses. Every time you run it, it comes from a different IP address, and you really don't want to open up access from that massive IP range just to make things work. So in this demo, we'll fix that using border zero by giving your GitHub action a real identity and routing its traffic through a static IP address, one of your own exit nodes. So that way, GitHub Actions can securely reach your private infrastructure, internal APIs, or even Kubernetes clusters without any firewall changes. All it takes is a border zero service account and a few lines to your workflow file. Let's dive in. So first up, let's talk about exit nodes. So imagine your GitHub action needs to call a third-party API, but that API only accepts requests from a fixed IP address that you need to allow list. So you need to make sure that all the requests coming from that action come always from the same trusted IP address. Now, the problem here is, like I mentioned, GitHub's runners use this huge, constantly changing IP address pool. One day you come from San Jose, an hour later it comes from Iowa. You never really know what IP you're going to get, and that makes allow listing basically impossible. So we're going to solve that with border zero. We route all of our GitHub Actions traffic through our own infrastructure using an exit node. And that way, all of your outbound traffic comes from a predictable, stable IP address, one that you control and that you can allow list. So to get started, first off, we need an exit node. Creating one is super simple. Just go to the border zero dashboard. We create a new socket of type exit node. We'll give it a name and we link it to the connector. In my case, I'll link it to my connector in AWS Montreal. And right there in the UI, you can now also see the egress IP of this exit node. And that will be the IP address our GitHub action will use from here on out. So now that we have our exit node set up, let's switch over to GitHub Actions. I've already created a workflow YAML for this demo, so I'll just quickly walk you through what actually happens here. So first off, we check out the repository, pretty standard, so the runner has access to the code. But then next we do a quick curl to ipinfo.io, and that will show us the current public IP address, just to see where our traffic is coming from before border zero kicks in. So next up, I'll install the border zero client, and we'll use this to set up a secure WireGuard tunnel. We authenticate using a border zero service account, and that token is already added to GitHub secrets. So from there, the client starts the VPN tunnel, and we set up an exit node, and we'll use the exit node that we just created. And finally, we use that same curl command again using ipinfo.io to check the new current public IP address. So I already ran this, so let's take a look at the output. So as you can see, before the tunnel starts, the IP address comes from a GitHub runner, in this case, a Microsoft IP in San Jose. Now, after setting up the exit node, the IP address now comes from an AWS instance in Montreal, and that is the connector that we just used, and that's where the exit node is running. And so now all of the traffic from this GitHub action runner consistently comes from a predictable trusted IP, one that you control. So far, we've handled outbound traffic from our GitHub action using an exit node. But what if your GitHub runner needs to do more than that? Like maybe needs to SSH into a server, call a private API, run some database commands, or deploy to a Kubernetes cluster inside your VPC. So with border zero, you can give your GitHub action a real identity. So one that's scoped with tight policies to define exactly what it's allowed to access, when, and even what it is allowed to do once it's connected. So in the second part of this demo, we'll take a look at a similar GitHub action workflow that runs some kubectl commands. Let's walk through what it does. So just like before, it checks out the repository, installs the border zero client, it authenticates with a service account, and it starts the WireGuard connection. So from that point on, the runner has an identity, and it can only do what we've allowed it to do in the border zero policy. So in this example, we're configuring kubectl, and we'll set the context to a Kubernetes resource we've made available via border zero called K8YVR. And then we run a simple kubectl get pods, followed by an apply to deploy a workload and a rollout restart on that deployment. So pretty straightforward, but the key thing here is GitHub Action can now interact with our private Kubernetes cluster without any firewall changes, without exposing ports, and without IP allow listing. I've already run this workflow, so let's take a look at the results. So you can see the job checked out the code, it sets the Kubernetes context, and then we deployed our new workload. All in just a few seconds. And best of all, everything is logged and auditable. So if we hop back to the Border0 portal, we can see both sessions from this demo, the earlier exit node traffic, and this one, which shows Kubernetes API access. So clicking on the session, we get a full summary. So first we see the identity of the GitHub action, the IP address, what Kubernetes resource it accessed, and the exact kubectl commands it ran. In this case, we see a deployment of into the default namespace, just like we expected. And as you can see, it's tightly scoped, fully controlled, and totally transparent. All right, that's it for today's demo. Just to recap what we did, we made our GitHub action come from a trusted, predictable IP address using Border0 exit nodes. We then gave that GitHub action a real identity, scoped with tight access control, and used it to deploy to a private Kubernetes cluster, all without having to open any firewall rules. And every action was logged and auditable, so you know exactly what your CI is doing, and you can control exactly what it's allowed to do. Plus, with Border0's built-in AI session analysis, you'll get notified the moment something weird happens. Like if your CI tries to maybe delete a pod or exec into a pod or anything it shouldn't be doing. And that's the power of treating your GitHub actions like real identities with scoped access and lots of visibility. So make sure to check out the blog in the link below. We got all the details and the code you need to get started in there. Give it a try in your own workflow. It's free to get going. So happy deploying securely and without having to expose your infrastructure to the whole internet.